What's up, guys and gals? Welcome to the Chapter 12 review for geometry. Here we will go through the 19 problems that you see in the chapter review there, and hopefully you are following, if you're one of my students, following my instructions to try these yourself first, of course, and then use this as help if you need it. So this is just an additional resource. If you find this helpful, that is great. But again, try the ones that you think you know how to do first. Use this just to help with the ones you don't. Euler's theorem. What does it say? What is it? I remember Fav 2. That's what I remember. My favorite two things, something like that, can help me remember that this is the formula. That it's kind of like F with a missing A, Fav, and then 2 comes after that. So we're going to apply those formulas here to solve for the missing part. So here are missing vertices. We're going to be missing this part right here. We plug in 32. Don't know V. We plug in 90. And this will tell us, we just work this out from here. You can subtract 32 from both sides. It tells you that your answer would be V is 60. So there should be 60 vertices for number 1. That would be a crazy looking polyhedron, 90 edges, 32 faces, 32, it's not a 32 gon. How would you say that? I don't even know how you would say a 32-sided polyhedron. I guess that's what you would have to say. I don't know if there's a shorter way to say that. I know there's got to be some sort of prefix for 32, but I don't know what that is off the top of my head. I know 20, icosahedron, but I don't know any higher than 20. So we have F plus V equals E plus 2. Once again, we know that F is what we're solving for. We know that vertices and edges 6 and 10, so we're plugging that in for this one. Sorry, oops. Plugging in that. There you go, Mr. Wagner, there you are. And this one we would have F plus 6 equals 12. Subtract 6 from both sides. You got F equals 6. This is your final answer for that one. And for number 3, same equation. This time we're missing the edges, so we're missing the E part this time. Let's plug those values in. We got 5 plus 5 equals E plus 2. With all of these, I hope you can just kind of see what it's going to be, but algebraically a good idea to solve it. So this should be 8 plus 2 equals 5 plus 5. We've got 10 equals 10 then, but algebraically, doing the steps, looks like that. You'll have 8 edges for something like that. So there's the first 3 coming from lesson 12.1. What you see here isn't totally comprehensive. We've taken, if you're one of my students, we've taken notes on each one of these sections. We had more than that, certainly, in 12.1, but this is some pretty important stuff from 12.1. You're going to see more than that on your test. All right, surface area now. Surface area looks like prisms and cylinders. We'll round to 2 decimal places if need be. So number 4, this is a prism right here. First, with prisms, you need to identify your bases. What are the parallel parts? And so here there's options. Sometimes there's not options. Sometimes you just have one pair of parallel parts. But you could use this and this, which I think most of you would probably use those two things because it's kind of the top and the bottom. But it's not always the top and the bottom being the bases. Look for parallel parts. Here this would also be parallel to this, and the front and the back would also be parallel. You could think of it anyway. But anyway you slice it, you've got surface area is 2b plus ph for a prism. So here you have 2 times, this would be 12 times 4, the way I have chosen the bases, and then the perimeter of the base would be 12 plus 4 plus 12 plus 4. If I add all that together, 12 plus 4 would be 16. You'd have 16 more that way. That would be 32 for the perimeter. And then the height being 9. The height is the part connecting the 2 bases. So this part is my h. And so from there, let's simplify. We've got 2 times 48 plus 32 times 9. 2 times 48, that'd be 96. 32 times 9, well 30 times 9 is 270. 2 times 9 is 18, so that'd be 288. And if I added 100 to 288, I'd have 388. This would be 4 less than that, so it should be 384 for my final answer. This is in meters, and it's an area. Surface area is going to be in meters squared. Number 5, here we have a cylinder now. We're going to have for the surface area of a cylinder. You've got two bases, so it's still that same idea. It's still 2b plus the perimeter times the height, but the perimeter with a circular base is now circumference. So think of it like that, but replace the b with pi r squared since it's a circle. Replace the c with 2 pi r since that's what circumference equals. So this is the formula we use to plug things into directly. So we have 6 right here, and we're going to have another 6 over here, and 5 for the height connecting the two bases there. This would be 2 times pi times 36. This would be 2 pi times 30. So there you have 72 pi. Over here you've got 60 pi. Altogether, it's 132 pi. It says to round to the nearest 2 decimal places, so I would take out my calculator at that point and see what that gives me. So 132 times pi is going to equal 414.69. So we have that as our final answer. It says to round, so we will round 414.69. This is in feet up here, so feet squared for an area. And then number 6, same idea, but here they give you the diameter. So that means that would imply that the radius is half of that, be 5.5. So careful, that might happen on the test too. This would be surface area, still the 2 pi r squared plus 2 pi r h. This is how I originally think of it, but this is what it is after you plug in what the things are. Your radius is 5.5, and we're squaring that, and here you'd have 5.5 over here. This times the height as 18. 5.5 squared, I don't got that one memorized. 5.5 times itself is 30.25. Okay, so we have 30.25 right here. And then 5.5 times 18, 99. Alright, so we've got 99 right here. This would be, looks like 60.5 pi. That times that, 2 times 30.5, and then this would be 198 pi. Put those two things together. Looks like we'd have 258.5 pi. And if we round that off to the nearest hundredth, nearest 2 decimal places, let's see what we get. 258.5 times pi. And there it is, 812.10 approximately. 812.10 inches squared. Alright, number 7 now. Surface area with pyramids and cones. These equations a little more complex than volume ones, at least. So a little bit tougher, but I still don't think they're all that bad. You just got to know what formula to use and then plug in the right numbers from there. And so on this one, it looks like we've got, I know the surface area of a pyramid, you'd have a base here, so you have to have the base, and then you have to find the area of these triangular faces, and then if you put them all together, that's the same as for 1/2 base times height for a single one. If you do 1/2 perimeter times height for a regular pyramid, it does them all at the same time. So that's our formula. This is going to be, it looks like this is 6 right here. That would mean that this part right here would be 3. We may need to use that. And then we've got 5. This is our slant height. And we may need to use that. We might not need to use that. It looks like we need to solve for h. I need to know what h is. I don't know what h is yet at this point. So this is going to require a little bit of side work. But notice that this is just a 3. This is 5 right here. What's the height going to be? You may notice that's a 3, 4, 5. That's a right triangle Pythagorean triple. But if you didn't see that, you could do this. We work this out, and we get h squared is subtracting 9. Subtracting 9, you get h squared is 16. Take the square roots, and you get h equals 4. So that's your height right here. H, this would be 4 centimeters for the height. So now plugging this stuff in. We've got 6 squared for the base. It's just 6 times 6. It's a square base right here for the pyramid. And then we have 1/2 times the perimeter would be 6 times 4. 6 times 4 all the way around. You would have 24 times the height we just calculated was 4. Simplifying all this, we get 36. Half of 24 is 12. 12 times 4 is 48. Putting those two things together gives you, I was going to write 74, that's 84. So 84, and this would be, I need to check something here, just a second. Yeah, something felt off about that. What am I doing here? I don't know. I just did this all for nothing. But hey, I make mistakes, but I catch my mistakes. I try to check my answers here, and so that should have been slant height. Oh boy. This should be then 5, so I totally did unnecessary work here, but this is how you would solve it. I think it's good to know because that might show up on the test. So this should have been a 5 right here instead, which would make this 60. You get 12 times 5 right there, and that would make that 96. That looks better. This would be 96 centimeters squared for your surface area. So sorry about the error there. I'm not going to stop the video and just record everything again. I'm human. I make mistakes. I made a mistake there, thinking too quickly about it. And so on this one, now moving to number 8, I could make a right triangle right there. It says it's a right cone, so straight up and down. Let's see if I need to use that though. So for surface area, I have the base. The base is pi r squared, it's a circle, and then the other part is pi RL. So do I need to find the height on this one? No. Could I find the height? Sure. I could do 6 squared plus the height squared equals 8 squared to solve for h, but I don't need it, so why find it? So I'm going to do pi times 6 squared plus pi times 6 times, this is my slant height right here, my L value right there, this is my radius right there. So times 8. This would be 36 pi. This would be 48 pi. Put those two things together, and it said it's to round to 2 decimal places here, so let's get it in terms of pi first. This would be 84 pi. That looks familiar. That's what I had over here. Plugging this into a calculator, though, 84 times pi. It's going to give me 263.89 rounded off. 263.89. This would be in inches squared. Surface area. And then number 9. Number 9, it looks like we're going to maybe have some side work to do here. Yes, it looks like we're going to have to find that area of the base. So we go back to this formula. Base plus 1/2 times the perimeter times the slant height. How convenient. They gave us a slant height. That's right there. They also gave us the side length. So you can think of that as S. The perimeter would be 4 times, there's 6 sides here, and it's saying it's regular, so I can assume that all these sides are the same. I have a regular hexagon, in other words. And what can I do when I have regular hexagons? If you want to use the apothem method, where you split it up into 6 triangles and you use apothem and you use trig to figure that kind of stuff out, that's fine. But remember, you can always split a hexagon, a regular hexagon, into 6 equilateral triangles. So we have a little shortcut. So here there's 6 equilateral triangles. And so for the base, we can say it's 6 times the area of one equilateral triangle. That's s squared radical 3 over 4. We use that equation for the area of one triangle. But we're going to plug in for s, we're going to plug in 4. So we have 4 squared radical 3 over 4. That plus 1/2 times the perimeter would be 4 times 6, which is 24, times the slant height is 4 rad 3. So let's work this out. We've got 6 times 16 rad 3 over 4. And this would be 12 right here. And 12 times the outside, the radical part is 12 times 4. That's 48. So we have 48 rad 3. From here, this would cancel with this like that. I could do that. And then I would just have 6 times 4 rad 3 on the top. Over 1 doesn't make a difference, so you have 24 rad 3 plus 48 rad 3. So these are like terms in a sense. You can add the rad 3 parts together. You'd have 72 times radical 3, and calculator time for that. So the square root of 3, same as rad 3, we'd get that, times 72. You would have 124.71 approximately. So 124.71, this is inches squared since it's a surface area. So good to go on those ones. Let's check out some volume things now. Volume, the side of a cube measures 8 centimeters. Find the volume of something like that. So let's split this up. These ones don't have pictures, but I'm going to draw pictures to help us visualize what's going on. That really helps to draw pictures. I won't draw the hidden line parts, so I'll just draw that part. So we got 8 centimeters everywhere, and the volume of a cube is supposed to be s cubed. It's still base times height. You can still think of it like that, the area of the base times the height, but since they're all the same, that ends up working out for a shortcut formula. So we have 8 cubed, 8 times 8 is 64, and then that times 8 more is going to be 512. So 512 centimeters cubed for number 10. Number 11, a right prism and regular hexagonal bases. Okay, so we have a hexagon base, and it's a prism, a right prism, so it's going to look something like this. And we'd have, I'll draw the hidden line parts here. We'd have that going on back here. The height is 37.2 meters, each with a base edge of 21 meters. So like that, the volume of a prism is supposed to be the area of the base times the height. So here again, I'm going to do some side work over here for number 11. And then this is going to get filled in right there. I'm going to be finding B. So B, you got a hexagon again. You can split it into the 6 equilateral triangles. So think about doing that first. And we're saying this is 21 meters. This is supposed to be side squared radical 3 over 4. We got that times 6 of them. And so we have to plug that in right there. So we've got 6 times 21 squared, s squared, radical 3 over 4, times 37.2. I'm going to erase this part here. So that goes along with this though. And it looks like they're not telling us to round, so I'm going to give you exact and approximate on this one. So we've got 6 times 21 squared. I felt like I had that one memorized. Is it 441? Yes, it is 441. So 441 rad 3 over 4. That times 37.2. So here you can think of this over 1. You can think of that over 1. If you multiply all the top stuff together, let's see what we get. So 441 times 6 times 37.2. That would give you this. Is that again 98,431.2. 98,431.2. You could have that over 4, but this is still times radical 3. I didn't multiply by that yet. If you wanted to get the answer that's in the book, we would have to multiply this by, it looks like you can multiply this by, you can multiply it by 5 over 5, and then you can reduce from there to get the answer that's in the back of the book that you should see there. But honestly, you can just approximate at this point. It doesn't say one way or the other, so I'm not going to show the work that it would take. But you could go 5 times 5 over 5 and then reduce the fraction from there to get the 123,039 rad 3 over 5 that they have in the back of the book. But let's type this into the calculator now. So this times radical 3 gives me that, and then that divided by 4 should give me the answer that I see in the back, and in fact it does. So we have 42,621.96 meters cubed. That's a pretty big hexagonal prism right there. 37.2 meters is pretty high. but that is number 11. Number 12, a right cylinder. So here's a cylinder. Sketch of the cylinder there. Has a radius of 3.5. So it looks like that's 3.5 inches. And the height is 8 inches. So what is the volume of that? Volume of any cylinder is, I'm going to get rid of this stuff. Don't need that anymore. Didn't really need that in the first place. I could just gone right to there. We have pi r squared, the base, times the height. And your radius given to you as 3.5, so just plug that directly in. The height is 8. 3.5 squared would be the same as 35 squared, with the decimal moved over 2 places, so 1225, okay, 12.25, and then that times 8. It's 98. We have 98 pi. Plug that in, 98 times pi gives me 307.88 approximately. So 307.88. This would be in inches cubed. All these are in volumes, or all these are measuring volumes, so all in units cubed. Don't forget units on the test. Volume of the pyramid or cone now. So gotta know those formulas. Remember, we saw this a couple times. We could take a pyramid and take a prism with the same base area and height, and it would take 3 of the pyramids to fill up the prism. So it's 1/3 base times height. You can do the same thing with cones compared to cylinders that have the same base and height. So this volume, 1/3 base times height. They give us the height directly. They give us the base length at least, so we can just do that times itself to get the area of the base. So 30 squared for the area of the base times the height would be 35. So here we have 1/3 times 900 times 35. 1/3 of 900 is 300, and 300 times 35. Oops, I got too many numbers. Hello. Clear that. There we go. 300. Did it again. But 300 times 35. I swear I only hit that 0 twice, but sometimes it does that on me. It's fickle. It's finicky. And this should be our correct answer. Yep. 10,500 inches cubed. Volume, cubic units still. This one, volume of the pyramid or the cone, doesn't matter with volumes if you have a right or a regular pyramid. It doesn't have to be going straight up. It can be oblique as well. You just need the base area and the perpendicular or the straight up and down height. So we have 1/3 base times height. It looks like this is an equilateral triangle right there. And so I can use that s squared radical 3 over 4 idea. But there's only one of them now, not 6 of them like I had with the hexagon. So I'm just doing 19 squared times radical 3 over 4. Hello. Somebody's slamming the door out there. And that times 23. And 19 squared, I think that's 381. 361. Oh, good thing I checked. Okay, 361. I'm ashamed. I'm ashamed. I didn't have that one down. This would be, we'd have 23 times 361 on the top. That'd be 8303 times radical 3. On the bottom I see 3 times 4, that's like this over 1, so I see 12 on the bottom. This would be an exact value, so you could say that centimeters cubed. You can't reduce this anymore. No factors in common, but to approximate that, type this times radical 3. You get that, and we divide that by 12, and we get our final answer approximated 1198. Oh, 0.43. Okay. So that many centimeters cubed. So here's exact, here's approximate. And number 15. That is a cone. The volume of a cone is 1/3 base times height still, but the base is a circle, so use pi r squared instead of a capital B. And it looks like that should be pretty straightforward. You are given the radius right here, you're given the height right here. You don't have to figure out the slant height with volume, so no need to do that. You could, but you don't have to here. That's 8 squared. Put that out there. Just plugging that in right there. And then 15. This would be 1/3 times pi times 64 times 15. I could do 1/3 of 15 first. That'd be 5. 5 times 64 would be 320. So I have 320 pi. And that would be an exact answer. This would be feet cubed. And 320 times pi gives me that value there, 1005.31 approximately. Yikes. There we go, sort of. That's better. And then let's check out some stuff about spheres. 16 and 17, find the volume, surface area of a sphere. I'll split this into 2 parts with the given radius. So I'll draw a quick picture. We're saying something like this, where this is 14 meters. So surface area for a sphere is 4 pi r squared. We're just plugging in the radius. It's given to us as 14. 14 squared is 196. And 196 times 4, what would that be? That would be 284, I think it is. 284. I'm sorry. That's 196, but 196 times 4 is 784, not 284. Silly me. There we go. And we have that much pi. Pi. So 784 times pi. What's your favorite kind? I'm personally an apple pie fan, but we've got 2,463.01 if we round that off. And this would be in meters. We're talking surface area to start, so meters squared to start. Volume, 4/3 pi r cubed. Got to keep those formulas straight. Make sure you know how to do that for the test if you're one of my students. And we've got this as 14 cubed. Now I don't have 14 cubed memorized, but 14 to the 3rd power. What is that going to be? 14 to the 3rd is 2,074. 2,744, excuse me. We have that. We can put that over 1. We can multiply this by 4. Is this reducible? Let's see. No. So I'll get back to what I started with there. So I have this times 4 on the top. I've got 10,976. That much pi. I can think of this as pi over 1 as well. I just multiply the tops together, multiply the bottoms together, and I get that value right there, which is approximately equal to, if I multiply this by pi, divide that by 3, it gives me 14 or 11,494.04. So exact answer again, approximate answer over here. Either one of these would be acceptable. If they tell you to round, then give the approximate answer. If they tell you to leave it in terms of pi, leave it in terms of pi. For number 17, another quick drawing here to help us visualize. This would be, the radius is 0.5 inches right there. So surface area for something like this, you'd have 0.5, squaring that. 5 squared is 25, so 0.5 squared would be 0.25. And 0.25 times 4, it's like a quarter times 4, you'd have $1 or 1 whole. So you just have, for your answer, pi. Your answer is pi, which is approximately 3.14 rounded off to the nearest 2 decimals. 3.14, this would be in inches squared. And volume, 4/3 pi times 0.5 cubed. That would be, I know 5 cubed is 125, so I know that would have to be 0.125. And then I can think of this as fractions like that. I'd have 4 times that. That would give me, that'd be 0.5 on the top, 0.5 pi over 3 on the bottom, which I could multiply both parts by 2 times 2 times 2. I could get pi over 6 right there. And when I type that into a calculator, pi divided by 6 would give me approximately 0.52. So 0.52 inches cubed for the volume. Number 18 and 19, our last two here, talking about now similar solids. Decide whether they are similar. So are they similar? If so, find their scale factor. So to determine whether they're similar, we need to check the matching up parts, matching up lengths, and see if the ratio is the same. So reduce the fraction. 40 compared to 20, is that the same as 12 compared to 6? We'd have, well, I don't know why I'm doing that way. This would be 2 over 1, or just 2. So is that the same as 12 over 6? Sure is. That's just 2 right there. You could just go right to 2 from here to here too. So these are the same. So I would say check, they're similar. Check that off my list. If so, find their scale factor. I just kind of found the scale factor right there. I already did that. So here's the scale factor. You can write it like that, or you can write it like this. And for 19, let's check it out. So check up all the matching, or check out all the matching up parts. This one matches up with this one to this one, and this one looks like it's matching up with this one. So are they all the same? Let's go small to big this time. We'll go 5 to 15, that would be 1/3. 4 to 12, looks good so far, that's still 1/3, but then 8 over 16, that's 1/2. So are these all the same? No, they're not all the same. They all have to be the same. So we can say these are not similar. And hey, that is the last review in the book. That's the last one. Hopefully you found that helpful. If you watch the whole thing, hey, I have no problem with that. That's great. Hopefully that helps you on your test. But again, this is not fully comprehensive. This is not everything that we learn. You need to study your notes still. If you're one of my students, go back to the notes. If you know everything in the notes and you can do the problems here and you can do the problems from your classwork that we did, then you'll be good to go. If you know the formulas, you got to have those formulas down, remember. So the formulas that we saw here, you got to have them down well enough to match them up. That's likely the way you'll see it, unless I tell you otherwise. If I told you got to know them letter for letter in class, then that's the case too. But it just depends on what I said in class. If you're one of my students, probably going to be matching, but you at least need to know them well enough to match them up. Okay, that'll do it. Have a good morning, afternoon, evening, whatever you got going on today. Have a good day, and well, I don't know, will I see you later? Maybe I'll see you later. If not, have a good one. Have a great life. I think you'll probably be watching another video or two still here and there, but that'll do it here. I feel like I should say more, but no, that's it. Have a good one. Bye, everybody.